have to list all possible. Remember, you're looking at the factors of the tail divided by the factors of the leading term. So all your factors of 4, plus or minus 1, 2, and 4, divided by plus or minus 1, 2, and 4. Well, that breaks down into a bunch of different fractions. You have 1, 2, 4. You can have 1/2. 2 over 2 is the same thing as 1. 4 over 2 is 2. But I can have 1/4. And that's it. All of that with plus minus. That's what that means. List all possible means list all possible. Then that's your answer. That's all your possible zeros. Yeah, if it says list all possible, that's what you do. And then the next part said use the graphing calculator to figure out where to start with your zeros and go from there. Well, graphing calculator I'm not going to let you use, so you just have to synthetic and go from that. But that's kind of the basic idea here. Okay?
Wait, is the quiz tomorrow still all calculated?
Correct. Okay. What was the next one? Was it 30 through 36?
Yeah, 36.
36, Mr.
Same deal here, 31 and 32. Basically, it's the same idea, guys. List all your factors from the tail end divided by all the ones that lead in term coefficient, plus minus, and that's how you figure it through. As we get into the second grouping there, where it said actually use the calculator to get an idea of where to start. This is stuff you won't be doing tomorrow, obviously. Well, when you use the zero root feature of the graphing calculator to approximate your zeros, what you're doing there is using that, you know how on your calculator it says analyze graph, then it says zeros? Bless you. That's what you're using. So if you look at your calculator, what is it?
We changed your picture. Wow, so that's what the other kid looks like?
Thanks. Yes, that's what the other one looks like.
Well, we never know because he's never on the back.
Thanks. So let's see here.
Recording what's going on because everybody laughed.
That was pretty funny. Look at 33. So if I have x, let me put in a graph.
Are those trying to be like?
Yeah, we had those stuff. Yeah, I have a really nice SLR that we never use because the iPhone takes such great pictures. Plus, you always have your iPhone with you. I'm doing 31 to show you guys how you would use your calculator to help figure out where your zeros are at.
Wait, are we having which
33, excuse me, 33.
Are we learning something new?
I have a couple things to show you. You know how you guys did where you did that long division yesterday?
Yeah.
I'm going to show you how you can use it with synthetic.
Oh.
It's a little bit easier.
And you need to get more classes out.
When we have this here, if we go to your graph then, it's going to give you that approximation like we did before. So all you would have to do is go in and, let's see if I zoom this a little bit.
I think that you have to like
I thought this one would work where I could zoom it. Oh well. Anyway, I can do that. So here you can do your approximate of zeros by your menu 6, 0, which is 1. And then you remember how we did that left-hand, right-hand boundaries? So you're just going to move your, oops. There's your left, just a little bit more here. There's your left hand. There's your right hand. And it'll start to give you zero values. So that's what you would be able to do. What's nice about the graphing calculator, when you get these lists of all of those possible zeros, you might get up to, I don't know, 15, 20 different zeros that you could approximate from. If I'm having you guys use a calculator and be able to go through and show the synthetic division, this tells me that I have a 0 at -1, which means I'm going to start synthetically dividing at -1 to break down the function smaller degree. It gives me a starting point of where to start at. That's all. Yes, ma'am?
But then it like gives you, like if you look at that other 0, that's
Yeah.
it gives you like a weird number.
Correct. That weird number, it's 1.7.
7.
That's the square root of
1.41.
square root of 2.
Okay. So you would just have to like
And what will happen is, depending upon the problem, it might say round it, and you can say your zero's at 1.14 or whatever it might be. But if you did it via the whole synthetic division, you'd wind up with zeros at, it was x minus 1, x plus 1, and then you'd have x squared minus 2 as your other term. So your zeros wound up at 1, negative 1, and plus minus root 2. That's what that calculator is showing you, but
Okay.
you did it this way with synthetic. That's all.
Okay.
It's rare, it's more often than you're not going to use your calculator to do that. It's not as clean as just going through the process. The calculator helps you if you've got a ton of them to know you got like a starting point. That's really what helps you with.
Okay.
That's it.
Yeah.
Okay. The rest of them are all kind of like that, beginning at 36, and what was the next? The next grouping was 40. Write a polynomial that has those for parts. Well, if your zeros are at 2, 4 plus I, and 4 minus I, those were the three zeros. So if those are your zeros, what you have to do is figure out what 4 minus, 4 plus I, 4 minus I. I think that was the problem. For 40? Yeah. Did you might have read it with the comma by mistake. Okay.
Yeah, that's why I was.
If what would happen is if that was the case, that meant you would have had 1, 2, 3. You would have had one more here and one more here, so you would have had 1, 2, 3, 4, 5, 6 zeros then. Because if this was a 0, then there had to have been a 4 minus I, and if negative I was 0, there had to have been a plus I as well. So you guys see what Izzy did there? She accidentally thought that there was a comma between those two. If there was a comma, that just means that the conjugates were not written out. Remember, if you see one term like this, the other one would be the conjugate. If you see one term, the other would be the conjugate. So this would have 6 zeros, so it would be a 6th degree polynomial. But since this one really only had the 3, it was a 3rd degree polynomial. So if 2 is your 0, bless you. If 2 is your 0, what's your term? X minus 2. Now with the other ones, remember, it's set up as x minus the 4 plus I. The other one would be x minus the 4 minus I. So what I'm going to do is distribute distribute the negative 1 out. And then I have x minus 4. Bless you. Oh, this was a plus here. I got ahead of myself. Okay? And now it's a matter of foiling it out. I accidentally wrote it. I wrote the plus here instead of distributing the negative. I just forgot to distribute. What I did here is I just used the associative. I just distributed out my negatives and rewrote it. Because now I can just FOIL from here. So I wind up with the quantity x minus 4 squared. The middle terms would be the quantity x minus 4 times I minus x minus 4 times I. The middle terms would drop out because this is nothing more than a really, really ugly version of a minus b, a plus b. So you just wind up with the difference of squares. Excuse me. So you get minus an I squared at the end. FOIL that out a little bit further. You had x squared minus 8x plus 16 plus 1. Very well could be, guys. It's just foiling. So you have the term of x minus 2. You have x minus 2, and then you got to distribute that to the x squared minus 8x plus 17. X cubed minus 8x squared plus 17x minus 2x squared plus 16x minus 34. X cubed 10x squared 33x minus 34. All I did with that step, you guys all freaked out at, there's an x minus 4. What I did here, to simplify it out, is I let a equal x minus 4, and I let b equal I. When I do that, I get a plus b, a minus b.
So B is I.
Right. I just used what's called U substitution. I made something nasty look something easier to work with. So I got a squared minus b squared. That's all it was. Okay. 42, same basic idea, but you have a conjugate of 1 plus I root 3.
Yeah, that's what.
When you see the conjugate written with that root 3 with an I, put the I out in front of the root. So you have negative 5, negative 5. What was the last part? 1 plus. This is 42. Yeah. Normally you and I would do that because that just means this was the square root of negative 3. You would have written it as I root 3. They put the I on the backside. I don't know why. It just, technically it's supposed to be after it, but it looks cleaner in front. That's all. Okay. So what is 42? So when you're dealing with 42, you have a repeated 0 at negative 5. When you have a repeated 0 at negative 5, that just means that the term is x plus 5 quantity squared. It's negative 5, so it would be x plus 5, so you just write it like that. So foiling that part out is easy. X squared plus 10x plus 25. The other part's a little bit trickier because you've got, since you have the 1 plus 3i, or I root 3, you should have a 1 minus the I root 3. So we do the same idea of writing it out in that nasty format. When you write it out with the nasty format, we have the x minus the 1 plus I root 3 x minus 1 minus the I root 3. Distribute out your negatives. When you distribute it out, you get x minus 1 minus I root 3. And then you have another x minus 1 plus I root 3. When you FOIL this all out, you're going to get the quantity x minus 1 squared minus the quantity I root 3 squared.
So then it would be -2
Perfect. On the inside of that, when you square the I, you get I squared, and then you get root 3 quantity squared, so you get 3I squared, which is negative 3. So you wind up with x minus, well, let me just FOIL that out, x squared minus 2x plus 1 minus a negative 3, which is
Is that X minus 1?
quantity squared? Yeah. Since it's I squared root 3, I squared times 3, it's negative 3. Minus a negative 3 is? You've been way too quiet lately. Get the plus there. So your two trinomials you have to multiply together then are x squared plus 10x plus 25, x squared minus 2x plus 4. Yeah. And whatever that works out to be. Yeah, you just FOIL that out, or distribute that out the rest of the way.
But once you get that though.
Then that's your answer.
Wait, question.
What write a polynomial that has those zeros? That was a different. We haven't gotten those yet. Well,
It's only this.
I think it was. Yeah, you're right.
So then I have, we have to multiply.
You have to multiply all that.
Oh, okay.
Yeah, because now when you get into, once you get into like ones like 48, what they're asking you here is that factor this knowing that you have a 0. So in 48 you have f of x is what, x cubed plus x squared. Yeah,
And then 3i.
and then telling you have 3 i's to 0. And Jenna, you're right. I would just group this one because you're done in like 2 steps. But the thing is that they want to show that it works knowing that you have a 0 at 3i.
Well, you can make it have a 0 at 3i because it's x squared plus 9.
I know. Do you guys all agree that you can group that?
Yes.
Okay. Let me show you why this works. When you group that, you get x squared plus 9, and then, what is it, x plus 1, I believe?
Yeah.
Okay. Which means you have zeros at plus or minus 3i and negative 1.
Wait, where did the x cube?
We grouped it. We grouped it, took GCFs, and did that real fast.
No, the
Skip
originals.
This
Oh,
is,
the f of x.
that is the original problem.
Okay.
What we did is we grouped it, and we got x squared, you got an x plus 1, and took out a 9, and you got an x plus 1. Okay. The reason that you can do this, and this was very similar, I was showing you guys the worst case scenario yesterday as we're running out of time, is that you can still use synthetic division with imaginary numbers. It's just a little ugly, okay? Let me show you what happens. If you know that you have a 0, if you know you have a 0 at 3i, that means you also have to have a 0 at negative 3i. So what you can do is you take your 3i and set it up for synthetic division. Because if you know that's a 0, what should wind up there? 0, okay? So here's what happens. You still use it the same way. Drop, multiply. What do I do between those two? I add. So what's 1 plus 3i? 1 plus 3i. Multiply again. When you multiply that, let me move this up a bit here. When you multiply that through, you're getting 3i times the 1 plus 3i, which gives you 3i plus 9i squared, which is minus 9.
Is there something?
I don't know. You can do long division as well. Works the same. And that's fine. I'm saying is that you can still use the synthetic division with this, and it still does the same thing. So now you have 3i minus 9. Now, you have to add going down, don't you? What's 9 plus 3i minus 9? 3i. And then you're left with 3i times 3i, which is 9i squared, which is negative 9. And lo and behold, notice all of these things add themselves through. You get 0. So now you've factored out the 3i. You can do the same thing now. Move this out, these two out of the way. You can do the exact same thing here with the negative 3i with the leftovers. Because I should still get a 0 when I'm done. So you drop the 1. Multiply. Add. Multiply. Add. And I'm left with 1 and a 1. Well, remember, you drop degrees each time. We started with the 3rd degree, 2nd degree, 1st degree, which means this is, and what's the 0 for the term, x plus 1? Negative 1.
You just
I
made
did.
that way more
And-
complicated.
You're right, John. It is a lot more work to go that way if you don't recognize that you can group it. Okay? Which means, am I going to ever give you a problem that you can just shortcut and be done?
No.
So, Caleb, what was the one that I think you said was 48? 48. We just did 48, but there was the other one.
That was 50.
50.
That was
Let's look at number 50 using this same idea instead of doing long division. Long division will work, but synthetic's a little bit cleaner. It's just getting used to having to FOIL things through. That's about it. So in 50,
Is it 0, negative 3? Yeah, I did it right. I'm good at math.
SMRT.
What, that's not 50.
Yeah, it is.
It was 5 plus 2i.
It's g of x in the book. I wrote f of x because I just keep doing that. So it's x cubed minus 7x squared minus x plus 87?
Correct.
Okay. So, and they gave you one of the zeros was what? 5 plus I? So they give you a 0 at 5 plus 2i. So knowing that you have a 0 at 5 plus 2i, I'm going to go ahead and set up my synthetic. Since I'm using I as a complex root, I'm going to space out the synthetics just a little bit more to have a little bit more space. Okay. So drop the first term like you would normally. Multiply out, we get 5 plus 2i. I add them coming down. I get negative 2 plus 2i. I multiply them through, which means I gotta distribute out. So when I distribute that out, I'm gonna get, what is that, 5 plus 2i times negative 2 plus 2i. I get negative 10 plus 10i minus 4i, so it's plus 6i. And then it's plus 4i squared, which is minus 4, so this becomes negative 14 plus 6i. All right. So I bring that back up. I add them coming down. I get negative 15 plus 6i. I multiply. Five times negative 15, I think is what, negative 75. 30i minus 30i. Okay, that's convenient. And then I have plus 12i squared, which is minus 12. And dun dun dun! Yay! Okay. So we verified that 5 plus 2i is 0. I do the same thing with the 5 minus 2i to this part. Because what I'm doing is that I'm factoring out the other term of the conjugate. It's dropping degree each time. So we have 5 minus 2i. Ladies, come on. Then I have to use negative 1, negative 2 plus 2i, and negative 15 plus 6i.
Wait.
Each time you synthetically divide, you're dropping a degree, and you just go back into that leftover part to keep factoring terms out. What's the other term? We only know one of the, we knew one of the zeros was 5 plus 2i. The conjugate has to exist, so it's 5 minus 2i. That's just 2 of the 3 possible zeros that we can get. I'm trying to find that third zero by utilizing synthetic. Drop, multiply, add, multiply. So let's see here, we have
The first negative.
It should have been positive one.
Yeah.
negative 5.
No,
No, it should have been
the
1.
negative 1 should be a 1. Like,
Oh, I saw the arrow. I thought it was negative. My fault. Thank you. So now that becomes 5 minus 2i. Well, that's a lot nicer. Sorry about that.
Hey, everybody's.
So I have negative 3. And now when I multiply it out, we're going to get negative 15.
You have positive
They get positive.
We still get positive 15 minus 6i, because we've got to get a 0 at the end. Which means this part here is x plus 3, so what's it? 0. Negative 3.
We have.
You can still go the long division if you want. Well, what I'm saying here is, if you use synthetic, it's a little bit cleaner, because if you went long division, you got to do that regrouping like this, and get the term, and then you got to divide out. It'll still work, guys. I just think that the synthetic version of it is a little bit cleaner. What do you got, Izzy? Did that make a little bit more sense on that? From wafer?
Last year I walked out crying on the word problem.
Oh, I did too.
I walked out of the room and I was like, I
No,
can't
like
cry
during the
always.
test, like there was tears on my paper, but I was like, I'm just gonna fail.
Right? This is on the first test.
Like,
It was an honors class. You're right.
I cried on the word problem. That was the only time I cried.
Yeah, that was, I only cried on the word problem once.
The last two problems were nothing more than using your graphing calculators and using approximations and going through there. I'm hoping that was pretty simple when you look at those. Okay. You guys owe me, what, the day 3 stuff now?
Yeah.
All right. Or do you want, you know what, give me the day 3 stuff tomorrow, that way if you need to finish and you want to fix a couple of them, that's cool, all right? We'll do that. That's fine. Thank you. That's fine. So then tomorrow with the quiz, a couple things that I was looking at.
That's what's gonna happen?
A couple things I was looking at. In the book itself, in the chapter, obviously, there's a chapter review in here. I think it starts, what page is this?
10, I think.
Yeah, 210-ish, in that neighborhood. 209. What you guys will see here is that it breaks things down into the different sections. And it does a really nice job of it. All right? We're only quizzing over 2425. And it's all non-calculator, so you have to start to think to yourself, how complex can I make it?
Complex, it's you find ways.
You know, can oh, that was yells. So here we go. Can you do conjugates? Can you do the fractions with the conjugates?
Oh my goodness.
No, it's the answer to that.
Yeah, we
I
did.
can't.
A long time ago, it feels like.
It does feel like
Oh, maybe I wasn't there.
How do you do this one? Well, how do you subtract fractions? What do you have to have?
common denominator.
So your common denominator here would wind up being 2 plus I times 1 plus 4I. So it'd be 1 times the 1 plus 4I, very good, minus 5 times the 2 plus I, and you're simplifying and go. That's not a difficult situation, okay? It's just ugly, okay? It's a whole idea of foiling and combining like terms. Remember that I squared is negative 1 when you distribute stuff back, okay? As you get back into the finding solutions, you know, find all the solutions to the equation. That is factoring, setting it equal to 0. What are your zeros? Find all the zeros of the function. That means you're finding all of the zeros. If it says list the possible, that's when you list them. Look at this. Beat the scroll on this thing. So let's see, we have find all the zeros. Use the rational zero test to list. List. If you have to list, what are your factors of the tail divided by the factors of the leading term?
Wait a second. Okay.
Okay. Find all the rational zeros. That means find all the reals, not imaginaries.
What did you say when it says list possible?
List possible is just what factors of the tail divided by the factors of the front. Okay. Write the polynomial function that has certain stuff. Okay. Okay. Can you write out the function? Things like that. Knowing you have a 0, can you go from there? Okay. Then it was a matter of factoring and finding all possible zeros.
And then when it gave us a 0, the synthetic like we just did.
Yes, sir. Yeah. Find all the zeros of the function. I mean, we didn't really do anything about discard the rule of sign, so that's not a big deal. But it all kind of boils down to the same idea. Can you utilize synthetic division to solve the problem? Can you go through and find your zeros? Can you factor stuff out when they're grouping and things like that? Looking for GCFs. Yes, sir.
Did we ever do the rational zero test?
Yeah, I was just saying that.
Oh, okay.
That's okay. That's when you do the tails divided by the front.
Oh, that's
That's what it is.
Oh.
That's all it
It's
is.
way different than both.
Yeah, of course. Of course. Because you have all the P's and the Q's and stuff like that. Well, it's all the factors of the last term divided by all the factors of the first term. That's all that needs for the rational zero test. It's much easier to say tails and leading term. Oh yeah, you guys need note cards still?
Yes.
I mean, other than that, I mean, there's no gotcha, there's no tricky thing. It's just a matter of looking at the problems that you have.
Wait, when it says find all.
That's fine. That's fine. All the solutions means find everything, including your imaginaries.